If you're learning to code, it means you probably have a billion-dollar startup idea in your head. But before you can execute that idea, you'll need to choose a tech stack. And you better choose wisely because it's a real pain in the ass if you decide to change it later. Every app is actually just a technology sandwich. And in today's video, I will teach you how to make a sandwich. We'll look at popular stacks like LAMP, Mean, Mern, Mevin, Fluff, Refi, Fart, Fancy, and so on. Then we'll architect our own tech stack from scratch and look at the decision-making process for each layer in the stack. By the end of this video, you'll know how to over-engineer a website like a true professional. If you're new here, like and subscribe, and let me know what kind of tech stack you're using in the comments. The OG tech stack is LAMP, which came about in the late 90s and stands for Linux, Apache, MySQL, and PHP. Building a web application in the 90s was a lot more complicated and typically required expensive commercial software. LAMP was a free and open source stack that eventually led to web frameworks like WordPress and Joomla. In modern times, building a web application is much easier, but tech stacks have become far more complicated because there's so many different companies selling shovels in the startup gold rush. That begs the question, what is a tech stack exactly? There's no official definition, but I would break it down into three parts. First, you have the front-end layer, which includes the tools required to build a user interface for the end user. On the web, that likely means a JavaScript framework, or for mobile, it might be iOS, Android, or a cross-platform tool like Flutter. At the other end, we have the back-end layer, which includes a server-side runtime like Node.js or Python, along with a database to store user-generated data. In addition, you'll likely purchase this infrastructure from a big cloud provider, and they'll try to lock you in, so I would consider them as part of your tech stack as well. Now, the third and final layer is APIs, which are the tools used to connect the front end to the back end. That might be something like REST or GraphQL that you roll out on your own, but mostly it includes essential third-party services that you absolutely need to run your app, like Stripe for payments, Twilio for text messaging, SendGrid for email, and so on. These tools often do things that fall into both the back-end and front-end categories, so we put them in the middle. Now let's take a look at some common tech stacks that you've probably heard of, starting with Mean, which stands for MongoDB, Express, Angular, and Node. The reason this stack got so popular is because it has a catchy acronym. It's important to make that acronym pop, because it will automatically make other people in the tech industry think you know what you're doing. Like on Fireship.io, I made up my own tech stack called Fancy, which stands for Firebase, Hugo, Angular, Node, Stripe, and Express. It works great, but sometimes I do regret choosing my tech stack entirely for the acronym. Others have realized this with the Mean stack, and there are variations like Mern and Mevin, which use React and Vue respectively. The reality though is that these acronyms don't accurately capture everything you really need in a tech stack. If you want to see what other successful companies are using in their stacks, there's a website called stackshare.io. You can see how popular technologies are and which companies are using them. Let's go ahead and build our own from scratch. But the first time around, let's use the hottest of the hot technologies at every single point, regardless of cost or complexity. Don't worry, by the end of the video, we'll come back and simplify things in a much more practical way. Let's imagine we're building the next MySpace, an app that requires user authentication, a database to store user-generated data that needs to scale around the world. Let's start by architecting the front-end layer. The very first question you need to ask is, where will my customers be consuming the application? Is it the web, iOS, Android, desktop, IoT, or something else? For this app, we'll assume that our customers are primarily on the web, but we might also want to build a mobile app in the future. When targeting the web, the programming language in your front-end layer will almost always be JavaScript. There are tools that can help you avoid JavaScript if you really want to, but if your goal is to build a killer web app, I would highly recommend embracing JavaScript. But we need this app to scale, so we're not just going to use vanilla JavaScript, but instead TypeScript. That adds a type system on top of JavaScript, which might help us catch bugs earlier and deliver more reliable code. The next thing we need is a UI framework, because trying to build a complex UI with vanilla JavaScript is very painful. There's too many options to even analyze, but I have a video comparing 10 of them. I'm choosing React for this app, not because it's the best or the fastest, but because it's the most popular. Sadly, many decisions end up being a popularity contest. As much as I wanted to choose Svelte, I know that choosing React will give me a much larger pool of developers to hire in the future. On top of that, I can more easily add React Native to my stack to build a mobile app. But React on its own is still not enough for our web application. We heard on the street that we'll need a state management solution if our app has any hope to scale. There are dozens of different state management libraries for React alone, but we'll choose the most popular option that everybody also hates the most, Redux. It allows us to write a lot more boilerplate code, which is awesome because we all know that more code leads to better quality apps. Now, another glaring problem with our tech stack is that it's currently using vanilla CSS. It's basically impossible to make CSS look good on its own, so we're going to bring in Tailwind. That'll give us a bunch of pre-built utility classes to style things quickly in exchange for some crazy looking HTML. We're also going to want a CSS preprocessor like Sass. Just like TypeScript, it provides some extra syntax to help us write code more efficiently. And we're also going to need PostCSS to purge any unused styles from our codebase and prepare our CSS for production. Now at this point, we have almost everything we need to build the front end. The only thing we're missing is a module bundler, which takes all of our raw JavaScript files and combines them into a single bundle that can be used in the browser. There's many options to choose from, and they're notoriously frustrating to configure. I'm going with Webpack, which is the most popular option today. That'll give us almost everything we need for the front end stack. Now it's time to switch gears to the hard part, the back end. The most important decision you'll make here is the database for your user-generated data. A good option for us might be a NoSQL document database like MongoDB or Firestore. They're easy to learn, inexpensive, and can scale to practically any workload, but they sometimes struggle to model certain types of relationships, especially things like a social graph that we might want for our MySpace clone. The most popular database option out there is the relational database, like MySQL, Postgres, and many other options. These databases are great at handling relationships, but they're not quite as flexible to changing requirements and generally more expensive to operate. There's also more exotic graph database options out there, but in this demo, we'll go with the gold standard of MySQL. Now that we've chosen our database, we find an article on the web that says it's not going to be fast enough at scale. To address this, we're going to add a second database to our stack called Redis, which is often used as a cache because it stores all of your data in memory as opposed to the disk, which is much faster to read from. But in order to put these databases to work, we need a server-side runtime where we can write code to access data and then send it back to the front end. There are tons and tons of options to choose from, and often the decision comes down to the programming language that you're most comfortable with. If you like Python, there are frameworks like Flask and Django that help you build server-side web applications. There's Ruby on Rails, Laravel for PHP, Spring for Java, and so on. As a JavaScript developer, I'm going to go with Node.js as my runtime, and then use a framework called Nest to handle the server-side web application stuff, because it supports TypeScript out of the box. We also don't want to have to write raw SQL queries, so we're going to bring in an object relational mapper like TypeORM. So that gives us a runtime for writing and executing code on a server. But in order to make that server available to the world on the internet, we also need a web server like Nginx or Apache. So let's throw one of those on the stack as well. But now that we have a server framework, we need to figure out how to deploy it. Before we can do that, we need to standardize the environment for our code by containerizing it with Docker. This creates a standard Linux environment that we can then use to deploy our code to any cloud server. But as our app scales, we'll need to orchestrate multiple containers. So for that, we're going to bring in Kubernetes. Then we'll need to choose one or more cloud providers to host all this infrastructure. Let's go with Amazon Web Services to give us the most complicated user experience. Now, because we're smart, we're not going to just go on AWS and click on buttons. Instead, we'll use Terraform to programmatically create our infrastructure and version it for better reliability. Now, we also need a place to host our actual source code, and I can think of no better place than GitHub. The reason we want to host our source code in the cloud is to set up a continuous integration pipeline. We can add GitHub actions to the stack to automatically test and redeploy our code anytime we push an update to the repository. That gives us a solid backend, but there are many things our app needs to do that are just too complicated to handle from scratch. One of those things is building an API for our front end and back end to communicate. We heard on the internet that GraphQL is awesome, so we're going to add it to the stack along with a library called Apollo, which will provide code on both our front end and back end to help us build a GraphQL API, which allows the front end to securely communicate with the back end. Another thing we're not going to want to do is deal with payments, so for that, we're going to bring in Stripe, which provides SDKs for both the server and front end to collect payments. We also don't want to deal with user authentication, so we'll bring in Auth0 to handle that. We also don't want dudes uploading dick pics to our platform, so we'll bring in Amazon Recognition with its deep learning dick detection capabilities. We also have no idea how to send text messages to our users, so we'll bring in Twilio to help us with that. I could keep going here, but you get the idea. We use APIs to help us for the things that are too hard to do on our own. At this point, we have a nearly complete tech stack, but it's likely way more complicated than it needs to be. It's important to keep in mind that your end users don't care developer and will never know what technology you use to build the application. They just want to have a good experience, and if you don't build a good experience at first, you'll never get to the point where you actually need something like Kubernetes. Let's go ahead and throw this entire tech stack in the garbage and start from a plain HTML file. Now, our web app does need to be interactive, so we need some kind of JavaScript framework. Instead of something big and heavy, let's throw in a new option called Petite Vue. It has a syntax that's compatible with Vue.js, which many developers out there already know, and we can drop it in with a script tag, so we're not even going to need a module bundler like Webpack. When it comes to CSS, we'll throw in Bootstrap, which is a little more cookie cutter than something like Tailwind, but is probably the quickest way to get to a decent looking UI. If we decide we need a mobile app, we're going to bring in Ionic to wrap our application in a web view, allowing us to quickly ship it off to iOS and Android. That takes care of our front end stack. To simplify the back end, we'll bring in Firebase. It gives us a document database that can scale without any need for a back-end server. It also handles user authentication, and we can include it in the application by simply adding a script tag to the document. Now, we still might want to write some server-side code, in which case we can use Firebase Cloud Functions, which is a serverless option that allows us to write code in Node.js, or Python or Go if you prefer, and deploy it with a single command without ever having to worry about the server configuration. It scales automatically without ever having to worry about Docker, Kubernetes, or Terraform. When it comes to continuous integration, we're just not going to worry about it. Unless you find yourself testing and redeploying your app every day, it's probably just a waste of time. We can also get rid of GraphQL because it's more well suited for complex apps that have multiple APIs to stitch together. And that leaves us with the Petite Fire stack, which is quite possibly the easiest way to build a full stack web application. I'm going to go ahead and wrap things up there, but if you want to learn more about building full stack web applications with Firebase using multiple different front-end frameworks, check out Fireship Pro to get access to my full courses. Thanks for watching, and I will see you in the next one.